started here.
Yes, sir.
Thank you.
All right, so start with a word of prayer. Dear Heavenly Father, please thank you for this time we can be together and talk about your creation and help us to learn more about you through this. In Jesus' name I pray. Amen.
Amen.
All right, so today we are going to talk about the sun. So we have a list of some things that the plants need in order to grow well. And so we have talked about this last time. We got the sun, we have water, we have minerals,
Yes.
soil, and I added heat. They do need heat, and so the sun provides that. So we're going to kind of go through this list a little bit as we go through these classes and dig down a little deeper into each topic. So I wanted to cover the sun. Not that we have a lot of control over it, but we can adapt to what it is doing currently and make plans based off of what we know it should be in the future. So we have some of the things that the sun will do for plants. So the first thing, it's going to warm the soil so that seeds can germinate. That's important. It also kills fungus and bacteria with its ultraviolet light. So that's one of the benefits of having sunlight as opposed to maybe artificial light. It also drives the photosynthesis process, which is the process that takes plants absorb the sunlight, and the energy from the sun splits off different molecules from water and carbon dioxide, and so it generates sugars based off of that. So that's important. Without that, the plants wouldn't be able to grow. And then also, plants need about 6 hours of sunlight, so it's something to keep in mind when you are planning where you are going to put your garden. So the sun warms the soil, and so that's something you can be thinking about. Soil temperature is important when we're trying to grow plants. So there's two different ways that you can sow seed. One is in pots in a house or a heated greenhouse, somewhere warm, or you can direct sow them out in your garden area. Just put the seeds in the ground, cover them up, and they'll germinate that way. So there's reasons why you would want to do different seeds different ways, because some require a long growing season, others grow very quickly once the weather warms up. Some are more larger seeds that are easier to sow out in the garden. Other times they're really tiny, and you may want to do them in the house to protect them, to get them going a little sooner. Or things like carrots. You wouldn't want to put those into little pots and try to transplant them out, because the roots can get messed up and get crooked, and then you get crooked carrots. So
So you're gonna give us a list of what we should start in the house?
Yeah, we can do that. Next time.
Okay.
Okay, and then I have a little handout here for you.
Cool.
So
Nice.
one of those and pass it on. So this is a chart showing germination temperatures and how many days to germination you should expect when the soil is at a certain temperature, and also the percent of germination. So on the left column, you'll see in the dark blue there, you'll see the name of the crop that you're trying to grow. And there's quite a few on here. Not everything is on the list, but you can look for maybe similar things. So if it's, most beans are all about the same, and most cabbage type crops, kale, are all kind of about the same.
Can you recommend a thermometer?
RioTemp. So this is actually a compost one, but it works. It's fairly accurate. You can also just go to like Walmart or some baking type store, Fred Meyer's, I suppose, or whatever, Rite Aid maybe, and get like a 6-inch one. So you basically only need to measure about 6 inches down, And that's going to give you that first top 6 inches are usually going to be about the same temperature. And
I've
sometimes even
never
down
heard
further
of
than
using a
that.
thermometer.
See, the things are around.
I know.
Okay.
Yeah. So, so if we want to look at for a different plant here, let's take a look at a common one that you'd want to do out in the ground, such as snap beans, third on the list there. So you can look at these zeros on here represent the fact that if you put it in the ground at that soil temperature, you get a big 0 out of the seed. You get nothing, so they won't germinate. And so there's no good reason to put them in the soil when it's too cold, because generally they can rot very easily at that soil temperature, or little animals will come around and devour them if they're not actively growing. But generally they can rot very easily. So you want to look for generally about 7 days is a good germination. There are some seeds that require longer than that, and sometimes, what is it here? Parsnips, those require almost a month to germinate, if I remember right. Let's see if it's on the list. Yes, parsnips. Yeah, so like at 50 degrees, takes 27 days. So they can get down to 15 days at 77 degrees. But I've been told in my experiences they do take a very long time to germinate unless they get perfect ideal conditions. So this gives you a guide here. Those things like peas have a much lower germination temperature. So like 14 days, they can handle 50 degrees. And even at 45, they can still do fairly well. So generally, it's 45 degrees soil temperature this time of year, or kind of year round. Once you get down to a certain depth, the soil is fairly consistent. You may get some frozen ground right at the surface.
I have a question. So how long and what time of day do you measure the soil?
Generally around noon or so that you get a little more consistent.
And how long do you need to have the temperature in there?
Well, just so it stabilizes. I mean,
Okay.
you stick the thermometer in there, wait a couple minutes for it to
Oh, just a couple
go
of
down.
minutes.
If
Okay.
it stops moving, then you know it's stabilized, and you can
Okay.
take a reading off of that. Or if it's have a digital one, it's usually fairly quick. But
Okay.
even then, you kind of want to wait at least a few minutes for it to settle down and get a reading off of there. Any other questions?
Is sprouting something different?
Yeah, you can sprout them. So that's another method. Before you plant them out, you could sprout them. The problem is that if the soil temperature is still wrong, they're not going to do well. So generally you want to, make sure that they're in the soil at the right time. But that is something you could try. I generally don't like to do that because you have to kind of count all your seeds out ahead of time and kind of figure out exactly how many you want to do, rather than just start putting them in. Counting seeds can be quite a job, but
Yeah.
it can be done. If you're only going to do like 10, you can count out 10 bean seeds and do that. It can also that can be a test as far as like a germination test. You can decide, so on a package of seeds, they always have a % of germination rate. Well, you can figure that out yourself. If you save your seed, or you just want to make sure, verify that, hey, you are getting 90+% on there by you take 10 seeds, you put them in a wet paper towel, put them in a Ziploc bag that's not sealed up, but just kind of open, so there's a nice moist environment. Set it on top of some warm surface like a refrigerator or freezer that's kind of emanating heat usually most of the time, and wait till those germinate. And you say, okay, well after a week or so, usually it's faster, usually like 5 days, usually you can get them to germinate. It's like broccoli or something like that. And you count them up and say, ooh, there's only 8 there. Okay, there's 80%. So you have an 80% chance on average that you're going to get 80% of your seeds going to germinate. The rest are 20% is not. So you always, if you want 10 plants, you need to allow for a few extra, another three seeds or something to plant, or plan ahead and think of, oh, don't always just plant the exact number of plants you need, because either they'll die later on, usually around 10% more than you need if you're doing a fairly large quantity. If you only need 2 plants, well, you may want to do 4, like zucchini or something, where you want 2 plants. Well, plant 4, because chances are
You're gonna get a large zucchini.
they're going to die. So you pick the 2 nicest ones and you chuck the rest out. Or you save them, and then when the little animals come at night and devour them like the slugs, and then you say, oh, I still have some, let me put another one out. And you put them back, have some replacements handy, because sometimes things don't always go the way you might expect it to.
Do you recommend soaking the seeds overnight before you plant them, like beans and stuff?
Well, the trouble of doing that is I mean, it's a good thing, but there's also the negative is you got to count out your seeds so you don't have a bunch of waste, because otherwise it's like, well, I can soak the whole packet, I guess. But then they're also very hard to work with. So you either have to have tweezers, because they all want to stick to each other when they're damp. And so that's the challenge of doing that, and I really haven't seen a benefit that's worth, there's putting them in the ground and just putting them in, watering the soil, nice moist soil, they do just fine. And so I haven't really seen enough reason to, because the negatives, that is an option there. So then transplanting, so you want to transplant generally about the same soil temperature that they would normally germinate at. So if you have like a tomato, don't set it out when the soil temperature is 45 degrees. The roots won't appreciate it, and the shock too of being in a nice warm house or something like that, or a greenhouse. Now the soil is cold outside. You kind of want the temperature to. So like tomatoes, they should be on the list here. So 8 days, 6 days. So I would say at least 75 degrees soil temperature before you set out your tomatoes. And that's midday too, so at night. Nighttime temperatures for tomatoes I think is like 55 at night, 60 somewhere in there. So you don't want the nighttime temperatures to be too cold, like in the 40s at night, then they're not going to be happy at all. So each plant has a very, you have to kind of learn for each plant. So generally you don't want to do like 15 different types of plants when you're first learning. Kind of do like 3 or 4, learn, practice on those plants, and then kind of do some research on the internet or something like that of what these plants need, what soil temperature do they like, how soon do you have to start them. So like green beans, you could wait till the soil's 65 degrees and then you just direct sow them out in the garden. Works well. Or for broccoli, you want to start them 6 weeks before the last frost date. So March 15 is a good date to start things, so we can set it out about May 1st for transplanting. So and we'll probably do a whole class on transplanting this and starting seeds if people are interested. Sometimes it's easier, especially when you're first starting, to go to the store and just buy some starts, because that part of the learning experience doesn't have to bog you down. You say, well, okay, well, I can go put it out in the garden and I can practice taking care of it, and you don't have to worry about the whole, because it's I would say more complicated to start a plant than it is to finally grow it out. It's going to take a lot more care in babying it and making sure that all the conditions are right. So start out with do something easy, especially if it's a new type of plant you've never grown before. Go get a start at the store, and like eggplant or something like that. Don't try to start eggplant by yourself. Just go get a couple eggplants. They're cheap enough, and you have much better success. It's already been taken care of and it's been well established already.
Do you recommend organic?
Not really. It doesn't really matter. It's, organic is mainly good for the produce that you're buying. Has it been sprayed, or did they actually And organic doesn't really mean that it's any healthier a lot of times, because the organic growers aren't necessarily, they're just using different fertilizers. They aren't necessarily taking care of the soil or, putting a lot of minerals into the soil to make the food more healthy. They're just putting on their organic versions of the same stuff. And so a lot of times they're no more nutrient dense than the conventionally grown. And sometimes the conventionally grown stuff is actually better because the farmer has better soil, or they took care of it and they did amendments, and they're trying to help the plants be super healthy, and so they can get a nice looking product. And so
How about heirloom seeds? Do you recommend those rather than regular?
not necessarily, because they're going to be less vigorous, especially if you get like a cucumber or a broccoli. They're not generally going to do as well. They're going to be less prolific. Generally a hybrid, it's just kind of like two very different people getting together and having children. Those children are generally going to be smarter and more intelligent and more healthy because of this mix of the genes. It's like inbreeding almost. Inbreeding is not necessarily a good thing. And in the plant kingdom, it's kind of inbred. You have this one variety that's been propagated over, and so it's not going to be generally as vigorous when there's two different types of varieties and they combine them and they get their seed, and then that's a nice vigorous plant. So I tend to do both. I like to save my seed and reuse it. So therefore I use, it's called open pollinated or heirloom. Heirloom just means it's old. Generally open pollinated, but open pollinated can be, someone developed one just like 5 years ago, and they've worked out all the changes over time. They keep planting it and selecting for the characteristics that they want until it's consistently giving them the same variety every time they plant it. So that's open pollinated. So that's if you want to take the seed and you want to save it. So like a tomato or something like that, very easy to save the seed on those. And tomato seeds, you only get maybe 15 or something in a packet. So you think, wow, I could, for all that, with the amount of money that's there, I could have easily saved 1 or 2 tomatoes and gotten 50 seeds out of it. And so they're very easy. But if there is a hybrid, you can sometimes get a decent tomato out of it the next time, but it's not going to be quite the same or quite as good, and maybe not have as good a flavor. So generally you want open pollinated if you want to be saving your seed over again. But I've done cantaloupe. I saved the seed. It was a hybrid. Planted it back. Got a nice cantaloupe. It turned out fine. Sometimes you get some weird stuff. Like squash is usually very bad at getting crossed. A cross of that, the next generation, which is an F2. The F1 is like the first generation. That's the hybrid that you would buy, and then you plant it again. It's now an F2 generation, and usually the squash gets all funny. It gets, you get a zucchini looking like a pumpkin, and they have bumps on them, and they don't taste sweet if it's supposed to be like a winter squash that has a good flavor. Well, you plant it at hybrid again next year, it doesn't look so good. It's kind of usually bumpy or lump. It looks like a pumpkin or something like that, or it just gets crossed easily too. So if you have your neighbors planting a pumpkin and you got a zucchini and you save those zucchini seeds, they're probably not going to turn out like a zucchini. They're going to be a cross, half zucchini, half pumpkin. So something to think about there. Okay, so we got. So the sunlight will kill fungus and bacteria, but ultraviolet light, UV radiation negatively affects plant pathogens. Pathogens mean bad creatures and fungus on your plants. So it also has direct effects. Direct effects can be ascribed to DNA damage, so that's going to affect the DNA of bacteria, and protein polymerization and enzyme inactivation. So these are some of the things that the sunlight can do to destroy the pathogens such as fungus and bacteria infections. and it can cause plant damage, but the plants have a way to kind of deal with that. It's very similar to the human skin. You know, too much UV rays can cause cancer or other damage to the skin, but the right amount that, you know, God designed us to have on going outside and getting some sun is very beneficial to us. So it's,
So are you saying then that a garden that's in full sunlight could have damage from the sun?
you can, especially like raspberries, they tend to don't like very strong afternoon sun. They can turn white on a what are those called now? There is a name, but I can't remember the little individual seed globs or whatever they're called. But yeah, you can get damage,
So they
and
can
certain
get, a garden can get
plants.
too much sun.
Yeah, certain plants don't like too much sun. Leafy greens like cabbage, kale, they tend to handle it all just fine. I'm trying to think of what plants. Probably some kind of fruiting plants can be damaged by too much sun. You could even on tomatoes. Tomatoes, you'll get a little bit of white leaves. Generally, that's getting burned by the sun. So if you wanted to know, this is a little too geeky, but polymerization is a process where relatively small molecules called monomers combine chemically and to produce very large chain-like or network molecules. So that's just kind of what the sun can do. UV rays potentially affect plants. So this is a good thing. So different types of UV rays, there's different frequencies. So they can trigger a secondary metabolite production. And so I talked about that a little bit last class session. Secondary metabolites is they're kind of like fats that the plant produces, and they put them into the leaves as a protection, so they can protect the plant from the UV. It's kind of like stimulating the plant to protect itself from the sun, almost like sunscreen that it's putting on. But there's a positive effect to pests as well, because that makes it very difficult for fungus to connect or get into the leaf and start to infect it and to feed off of it. And also bugs don't like to be eating leaves that have a lot of secondary metabolites in there. Essential oil is kind of the common name for secondary metabolites. So plants that, like oregano, don't tend to get a lot of animals eating them. You see, well, there's no pests on that one. Well, because they generally have higher levels of essential oils in them. And so even like a plant, like a kale plant, can have the same essential oils in there.
So I had white mold on my zucchini last year.
Yep.
And so can I put oregano and plant oregano around the base of my zucchini? I
You
can't.
could, but it's not going to help.
It's not.
No, it's a health issue of the plant. And so the plant doesn't have the ability to fend off the fungal infection.
So is that more of a seed problem, or is that more of a soil problem?
Soil, generally.
Soil.
Yeah, it doesn't have the nutrition it needs. It's not a healthy plant, and therefore it's weak and it's like someone with a weak immune system, basically, and you get an infection because of that.
So I just need more bacteria then.
Yeah, so yeah, a lot of bacteria in the soil it'll feed the plant with microbial metabolites, which are kind of very complex molecules that are already ready to go for the plant to use, rather than the plant having to manufacture all those. And then it's able to put a lot of the energy from photosynthesis into producing these
Okay.
secondary metabolites, which are kind of like essential oils. And those are what's going to protect the plant from things like powdery mildew, which is what you have.
Yes.
So let's see UV damage. Let's see anything interesting I want to mention on here. Specific So photoreceptors send signals to other parts of the plant that causes changes in growth and development. So I mentioned DNA repair enzymes. So So some of these enzymes, as mentioning here, will protect the plant from pests as well as protect it from the sun. So when it gets a little bit of sun, it's kind of like when you get on your skin, you start to get tan, and that tanning will help to protect you from the sun, that darkening. So that's the leaves of plants have that same kind of ability to react to the sun that they're getting. They see, oh, it's getting a lot of sun. It triggers in the plant to produce enzymes that'll help protect the plant, and that as well as that protects them from pests too. And then light prevents insect herbivory. I'm not sure how to pronounce that, but eating the plant is what that means. So light can increase the production of plant compounds like glycericides, which can make the plant smell and taste better. While many glycericides taste delicious to humans, they can be toxic to some insects. So that's another effect that the sun can have on the plants. It can help protect it from insects. So if it's cloudy all the time, that for a certain month that the plant can get weaker or not be producing these things, and so they can be attacked by caterpillars or something like that. The white cabbage moths like to lay their eggs. Birds are very good so when you see these little birds hopping around, don't scare them off. They're out there pecking the eggs and the caterpillars off your plants. And so you can see these white butterflies fluttering around your kale, but you may never see a caterpillar because they all get eaten up by the birds.
So white butterflies are good?
No,
Oh.
birds are good. Sometimes they eat the butterflies as they can catch them, but usually they're after the caterpillars after they hatch. So then photosynthesis is the main process that's beneficial for the sun, and so this is for you that here for those that were here, which aren't too many. Travis, I think, was here. Let's see who
Yes.
else was here. You were there? Okay. You were there too? Okay. All right, well, I have a new picture. So it isn't boring.
Yeah, it's more bright, I like it.
Yeah. So this is kind of looks like a piece of lettuce or something like that. So anyway, we have the sun coming in here, and we have carbon dioxide, which is important to have. If sometimes plants are actually limited in their growth because of a lack of carbon dioxide. So global warming is actually a good thing for plants. They appreciate it. They have a little higher concentration. But majority of what they're absorbing is actually coming from the soil. As bacteria are consuming the organic matter that's in the soil, it's releasing carbon dioxide into the air, doing like the decomposition process, and the plants are absorbing it and putting it back into the soil. So it's a circular process. And then they're bringing in water through the roots. So the photosynthesis process needs carbon dioxide and water. And the sun is like the electricity that kind of powers the process. It's the energy that knocks off different molecules. And then in that process, it releases some of the oxygen. So water is H2O. So I believe that means 2 hydrogens and 1 oxygen. And so and then notice over here CO2. So how many oxygens? 2. So we get 3 oxygens. If I remember right, sugar does not need that many. So oxygen is O2. So the carbon molecule is knocked off there and used in the production of sugar. Sugar, I believe, is 5 molecules of carbon, glucose, and so the oxygen is then released into the air for animals to breathe, and then the animals ingest the plants and fertilize the plants, and it's a whole nice little cycle. So, and then we breathe out carbon dioxide that the plants can then utilize too. So
singing and talking to your plants are good.
yeah, breathe on your plants, and they will appreciate it.
Unless you have bad breath. Just kidding. Just teasing.
All right, so then this is a little bit more detailed version of that. Through a plant cell, We get chloroplasts, which is chlorophyll, you may have heard is the green substance in plants, so the green cells. So this is a chlorophyll or a chloroplast. I'm not sure exactly the difference. That's very similar. So then we have a first mechanism of light coming in here, powering the chemical reaction. We've got water passing through 2 oxygens. I think the carbon dioxide combines with one of the oxygens of the water, I believe, or something like that. Anyway, we got 2 oxygens coming out the other end. And then we have some other mechanisms called ATP and some other things in here in Calvin cycle. And if we have time, there's a short video at the end that shows you the Calvin cycle. It's really neat to see all the interchange of molecules, how that goes. But it produces CH2O. Looks like for sugar. Comes out the other end. So outer membrane, it's kind of identifying some of the characteristics anyway. Stomata. It's always a nice thing. So stomata in a leaf is on the underside, and these little mouths that open and close, and that allows the CO2 into the leaf. And you think about it, remember I said the carbon dioxide or CO2 is coming up from the ground. Guess where the holes are on the bottom to catch them. It's like little umbrellas opening up to catch that CO2. Okay, and then chlorophyll. Plants produce chlorophyll when exposed to light for solar energy production and production of photodestruction, or protection from photodestruction. So,
Chlorophyll is really good for us.
yep, it's good to eat as well. So, and then some of the things we can look at as far as whether or not our plants are healthy and whether or not they have enough sunlight. So when plants are not getting enough sunlight, they grow tall and have skinny stems. So they they're looking up, trying to find the light, or they're also, it's a reaction because what God programmed into them. It's like if there's competition, if there's other plants are above them, they're going to try to grow up nice and tall to get above those other plants. Or maybe they're brothers and sister plants if you plant too densely. And so that's an indicator that, so internodes, it's kind of a technical term. So basically on a stem of a plant, we have things called nodes and internodes. The other ones didn't have nodes. Okay, so we got anatomy of let's see, this is the morphology as we call it. The physical characteristics of something. So then we have a main stem, and wherever there's a leaf or a bud, we call those nodes. And then the distance between those nodes, we call an internode. So that's what that term is referring to. The distance between the nodes can tell us quite a bit about how well the plant is doing, whether or not it's getting enough sun. Also the color of the leaves, whether or not it's dark green or if it's getting kind of yellow or purple. If it's purple, it usually has a phosphorus deficiency. So you can kind of take a look at the leaves. And there's actually whole diagrams because of the cannabis industry. They wanted to know how their plants are doing, so they made these beautiful little diagrams you can download off the internet that actually says, if your leaf looks like this, if it's green with yellow veins, it means this. It's deficient in this. Or if it's dark green veins, but the rest around it is getting kind of yellow, then it means this deficiency. Or if it's purple, then it means this. And so there's all these different characteristics. Or the fringe around the leaf is getting kind of brown. Well, maybe it's got burned, or maybe it's not getting enough water. And so that can be very helpful in kind of diagnosing your looks like, what's wrong with my plant here? What's going on just by examining the characteristics of the leaves.
Do you recommend one of those apps?
I was just thinking of apps.
It's not really an app. I suppose there could be. I haven't looked for one, but
I
it's
don't have
just
one.
like a graphic. You just like on Google Images or something. You just type in leaf something. What would you
Because I know
search
some
for?
of them are pretty expensive, but I would like to get Oh, cheap one.
Um,
You have to learn.
Yeah, well, it's just the graphics, so you can
Okay.
just, they're all free.
I'll just
There's
look
like
them.
10 different ones, and you just decide which one you like the best.
Okay.
Let's see here, plant, leaf, what did we call it here? Leaf analysis, or leaf characteristics, or how is my plant doing based off the leaf? Something
Okay,
like
I'll
that.
check that.
I might put one on a slide here next class. I'll look at that. Let's see here. Anything else that's interesting? So it needs more sunlight. It's basically saying there's some hormones that the plant produces when it's not getting enough that causes it to grow tall towards the top and start reaching for things. So a plant that is real thick stems and fairly short on the internodes. The leaves are fairly close to each other and it's real sturdy. That means you have generally a healthy plant. Let's see here. So there's always variations to that rule, of course. So more rapid growth. So if the plant is really growing fast, well, it can have, the internodes can be fairly long too. So don't freak out if you see your plant out in the garden that looks healthy otherwise, but you say, well, the nodes look awful long, spaced out. Well, that can just because it's growing fast and doing well too. But usually seedlings, you want a very short, stocky little seedling. So there's also characteristics where so if it's not doing very well, it will also lack like buds and it won't bloom generally. It's trying to stretch itself out and grow, but that usually will mean it's trying to reach for the sun and it's not focusing on producing fruit or blooms, or if it's a flower or something like that. Wind can stimulate and release the plant hormones, so wind can have effect on it. I put this in here not because it has to do with the sun, but because it's the same, has to do with the internodes and the vigor of the plant. So the wind can cause shorter internodes and a thicker stem. So just a little fan on your seedlings is a good thing. It'll stimulate them to be thicker and stronger, and they won't be so spindly and likely to fall over and break, which is not a fun thing to see your little plant broken in two, because that's usually lights out for the plant. Usually. Or a slug eating all the leaves off of a bean plant, and then you say, well, so much for that one, jerk it out, because they'll never come back if they lose their initial leaves. Let's see what else can be helpful here. Yeah, basically it'll strengthen the plants. So that's a good thing to have the wind there. Insufficient nitrogen, zinc can also cause short internodes as well, or cold temperatures. So sometimes you might have those situations, and so don't always get excited when it's short internodes. It could be something like that that's causing it. Also, let's see here. Zinc has there's a leaf malforming. The nodes of the leaf tend to be offset. They're not perfectly aligned. If they're a little bit offset, generally that means there's a zinc deficiency in the leaves, except for tomatoes, because there's a genetic characteristic in tomatoes that causes that same abnormality. And it's like, oh no, but it's actually just fine. They're not deficient in zinc. It's a genetic variation. But other plants, let's see what would be an example, like a bean plant. You could see that on the bean plant where the leaves are just a little bit off or crooked a little bit. And it means it didn't have enough zinc in the formation of those.
Can you just put a tablet in the ground, one that you saw?
Could, yeah. Could help. Spraying them with a water-soluble form of zinc probably would help. I think zinc is probably be fairly cheap to get. Look on Amazon for zinc sulfate or something like that. Okay, and then close up here. So where to plant a garden to get enough sunlight. So that's a good idea. It took me a couple years to figure out where I wanted my garden. I had all these great plans, like, oh, this would be perfect over here. And then one morning I woke up and went out there early and I thought, ooh, there's no sun out here. It's cold and frosty over here.
Whoa.
So this isn't so good. And then I went over to another part of my property and the sun was out and it looked beautiful out there in the morning. I'm like, oh, well, maybe I should consider this. And so I had to work after I had, taken a bunch of stones out and got all the ground prepared. Put all this work and realized, this isn't such a good spot after all. So it is good to think about, plan ahead, think about all the different options, consider your options, and don't say, yeah, I just want it over there. Think about where you want it.
So what if we have property that the sun in the morning comes and hits it, but then midday it doesn't, and then the evening it does?
Well, and it can work. So generally you want to be on the south side, unless you have a bunch of tall trees on the south side as well, or a bunch of tall buildings. What situation do you have at your place that you're thinking of?
Oh, well, my neighbors have 2 trees that will block the sun
Yeah.
during midday.
Well, it's not necessarily, that's actually could be a good thing, because that's the kind of the really, really intense sun could be blocked, and then, you still have a few
Okay.
hours in the afternoon. You kind of have to make do with what you have,
Yeah.
but you do the best, you kind of make the best choice. And 'cause mine, they generally say you don't want to be planting on a north slope. You want to be on a south slope. Well, our property just happens to be the top of the hill is the road, and we have the north slope. And so the neighbors have the nice property, which has a nice south-facing slope, and I'm like, well, do with what I got. And so we have all these tall oak trees that are on the south part of this property. So I had to push the garden all the way to the north side of the property where the sun can reach over the top of the oak trees, and we still have a decent garden, and it does fine. I would love it if, I have a little space on the southeast side of our property, out by our gate. I'm like, well, it's not very big, but it's got very good sun, and so I prioritize things that need good sun, like our tomatoes and peppers. They like a lot of heat, so I put those in that little area I got.
Mm.
So southeast part of the property, generally best for sun exposure, unless, of course, you have neighbors with very tall trees right then. So you just kind of have to watch during the day, and sometimes you go out there, oh, it's so beautiful and sunny, and then go out there a couple hours later, it's in shade. I'm like, oh. So you got to kind of look
Yeah.
different parts of the day. In the morning, hey, does it get early sun, or does it take till 10, 11 o'clock before it actually gets some sun on the ground? And then how soon in the evening does it actually get, is there some big trees that are in the way that are shading it towards the evening, and you lose all the evening sun too. So just kind of 6 hours is kind of like a good medium, kind of see, well, there's a couple hours missing in the day that it's not getting sun, but there's still 4 hours in the morning or something like that, and 2 hours in the late afternoon, maybe 2 to 4 p.m. it's still got sun, and so you probably will do fairly well. And then, should we look at a short video?
Yeah.
Close up
Yeah,
here?
video.
We need a movie.
Go ahead, popcorn.
You're facing a giant bowl of energy-packed carbon crunchies. 1 spoonful, 2, 3. Soon, you're powered up by the energy surge that comes from your meal. But how did that energy get into your bowl? Energy exists in the form of sugars made by the plant your cereal came from, like wheat or corn. As you can see, carbon is the chemical backbone, and plants get their fix of it in the form of carbon dioxide, CO2, from the air that we all breathe. But how does a plant's energy factory, housed in the stroma of the chloroplast, turn a 1-carbon gas like CO2 into a 6-carbon solid like glucose? If you're thinking photosynthesis, you're right. But photosynthesis is divided into 2 steps. The first, which stores energy from the sun in the form of adenosine triphosphate, or ATP. And the second, the Calvin cycle, that captures carbon and turns it into sugar. This second phase represents one of nature's most sustainable production lines. And so with that, welcome to the world's most minuscule factory. The starting materials? A mix of CO2 molecules from the air and pre-assembled molecules called ribulose bisphosphate, or RUBP, each containing 5 carbons. The initiator? An industrious enzyme named Rubisco that welds one carbon atom from a CO2 molecule with the RUBP chain to build an initial 6-carbon sequence. That rapidly splits into 2 shorter chains containing 3 carbons each and called phosphoglycerates, or PGAs for short. Enter ATP and another chemical called nicotinamide adenine dinucleotide phosphate, or just NADPH. ATP, working like a lubricant, delivers energy, while NADPH affixes 1 hydrogen to each of the PGA chains, changing them into molecules called glyceraldehyde 3 phosphates, or G3Ps. Glucose needs 6 carbons to form, made from 2 molecules of G3P, which incidentally have 6 carbons between them. So sugar has just been manufactured, right? Not quite. The Calvin cycle works like a sustainable production line, meaning that those original RUBPs that kicked things off at the start need to be recreated by reusing materials within the cycle now. But each RUBP needs 5 carbons, and manufacturing glucose takes a whole 6. Something doesn't add up. The answer lies in one phenomenal fact. While we've been focusing on this single production line, 5 others have been happening at the same time. With 6 conveyor belts moving in unison, there isn't just 1 carbon that gets soldered to 1 RUBP chain, but 6 carbons soldered to 6 RUBPs. That creates 12 G3P chains instead of just 2, meaning that altogether 36 carbons exist, the precise number needed to manufacture sugar and rebuild those RUBPs. Of the 12 G3Ps pooled together, 2 are siphoned off to form that energy-rich 6-carbon glucose chain, the one fueling you via your breakfast. Success! But back on the manufacturing line, the byproducts of this sugar production are swiftly assembled to recreate those 6 RUBPs. That requires 30 carbons, the exact number contained by the remaining 10 G3Ps. Now, a molecular mix and match occurs. 2 of the G3Ps are welded together, forming a 6-carbon sequence. By adding a third G3P, a 9-carbon chain is built. The first RUBP, made up of 5 carbons, is cast from this, leaving 4 carbons behind. But there's no wastage here. Those are soldered to a 4th G3P molecule, making a 7-carbon chain. Added to a 5th G3P molecule, a 10-carbon chain is created, enough now to craft 2 more RUBPs. With 3 full RUBPs recreated from 5 of the 10 G3Ps, simply duplicating this process will renew the 6 RUBP chains needed to restart the cycle again. So the Calvin cycle generates the precise number of elements and processes required to keep this biochemical production line turning endlessly. And it's just one of the hundreds of cycles present in nature. Why so many? Because if biological production processes were linear, they wouldn't be nearly as efficient or successful at using energy to manufacture the materials that nature relies upon, like sugar. Cycles create vital feedback loops that repeatedly reuse and rebuild ingredients, crafting as much as possible out of the plant's available resources. Such as that sugar, built using raw sunlight and carbon, converted in plant factories to become the energy that powers you and keeps the cycles revolving in your own life.
You know,
You serve an incredible God.
I know. Sheesh.
it's not just a simple process, it's
really
extremely complex. So that testifies to God putting complexity in there to make it the most efficient. So, because plants are very efficient at taking sunlight. We can't even, I think solar panels are like 10% or 20% efficient as far as they're able to utilize the sunlight. Only 20% of it. Okay, yeah, thanks for coming. But you know, plants are, I don't know, they're much more, I don't know the exact percentage, but they're probably, 80-90% efficient as far as they're able to use all the energy that's coming in to manufacture sugars. But they're not, plants are unselfish too, so we can learn lessons of unselfishness because about 60% of the sugar that they produce, they pump down to the roots to feed all the biology down in the soil. And so they don't keep it all to themselves, they're thinking of others, and so that's a lesson we can learn from, share. When we get an abundance, share, and God will give us more.
Yes.
So, any questions of things that you've struggled with, or a few more minutes here or questions about the sun?
We certainly need more sun though, so if we can change that, that would be great.
Yeah. Always need sunlight, and so some of the things that we can do to allow the photosynthesis process to be the most efficient it can be. Plants usually aren't being super efficient as far as they can only utilize the the nitrogen and what's coming up from the roots and the sunlight that's coming in. They're limited by things, and so I mentioned CO2 is a limiting factor. There's also minerals that are limiting too. So if the plant can't get a hold of certain minerals, it can only use, it has maybe 5 zinc molecules. Well, it can only utilize those 5, and then it's trying to get more, but there's more sunlight coming in that's wasted because it can't produce as much sugar because it's missing some of these characteristics. Manganese, molybdenum, iron, let's see here, what else? I do have a list here. Well, we should look at that sometime, but that's an important factor. So when plants are being unhealthy, we can stimulate them to be healthy by giving them the minerals that they're probably deficient in. Let's see if I can find it real quick here. So that would be under
So you give them a little bit of molasses.
yes.
It has a lot of iron.
So that is something, yeah, that's a good point. So molasses, being a sugar, it has minerals in there too, but you can actually feed plants sugar and it'll help them to overcome their deficiency. Let's see. Let's see. There we go. Okay. So, okay, iron, we got manganese, also known as Mn, zinc, are best applied as a foliar, as a sulfate form. Let's see, is that right? Let's see, one of these numbers here, okay. Oh, here we go. For complete photosynthesis, utilizing all the sun, plants require adequate levels. Means if you give them too much, they're not going to do it. Certain minerals can be toxic at certain levels. So adequate levels. Manganese, yes. Magnesium. So magnesium is easy to get. That's the Epsom salt. You can go to the grocery store and get Epsom salt. It's a good way to get it. Iron, nitrogen, and phosphorus. So it's not too crazy. Fairly easy to get a hold of those, but those are the 5 items that they need in order to have complete photosynthesis process. In order for that process to be functioning as it should, all those minerals need to be available to it. So applying those in a foliar spray can be beneficial to drive. And so I'm going to discuss in another class about how if you get the plant healthy and producing lots of sugars, it can allow the plant to get all the minerals it needs from the soil because it's feeding the biology which go out there and glean all those minerals. They're mining the minerals from the soil and they provide it back to the plant in a form they can use. And so you can, rather than dumping a bunch of minerals and amendments in the soil, you can just spray a little bit on the leaves and let the biology in the soil do all the hard lifting for you. And it's much more economical too.
What's the number, how many minerals did you mention? So
Um,
zinc, iron, magnesium, manganese?
There's like 4 or 5. Nitrogen is not really a mineral, but it's needed as well. So magnesium, iron, manganese, which is a little more hard to get a hold of, but and nitrogen and phosphorus. And I haven't found a good soluble form of phosphorus yet. It's good to have it water soluble, like in a little crystal salt form, something that goes into water very easily. I've gotten like a kind of a rock form of it, like gray powder, which didn't go into solution very well and just plugged up my sprayer. So, but generally phosphorus isn't too much of an issue, but it can be. But you can find it's like super triple phosphate or something like that. It was not a good idea. It's like little granules and not. I had to like grind it up and it still was a mess. So if you ever can find it in a crystal form, phosphorus, let me know. And I'm still looking for a good source for how to get a hold of that to apply that to my plants. But even the other ones are very helpful. So.
Do you know which states in this country are the best for farming and growing?
California.
That's one of the top
Well,
ones?
yeah, that's where a lot of produce comes from because it's such a good growing place. Warm weather.
What about the more humid states?
They have issues like growing tomatoes in Florida, very, very hard because they get fungal diseases very easily because of the high humidity. So low humidity is actually most good for plants because you get less diseases.
Got it.
Good irrigation, most of the places that like California don't have good rainfall, but they have good irrigation, a lot of rivers and places where they can get water from, groundwater.